Okay, so we are coming back to probability in this unit. We did the geometric and arithmetic sequences in series, and now we're just doing one, well, the rest of the unit is actually related to probability. So remember in our last unit, we learned about permutations. And I don't know if it was emphasized that in a permutation, the order in which you choose the elements matters. So therefore, there are more possibilities in the end. There's more, when they ask you to find how many ways can you choose a president, a vice president, and a secretary, well, that would be different and a lot more than how many ways can you choose 3 people from a group of 10. And I'll show you a little bit more in a minute. But now we're going to learn about combinations. And combinations is when the order does not matter. So when your order doesn't matter, your result is actually a number that's a lot smaller than if the order does. So for a permutation, you're going to have a bigger number than if you do a combination. So you can see that mathematically here that works because of the formula. Remember in a permutation formula, you had NPR, and that just equaled to n factorial divided by the difference between those two, n minus r factorial. Right? So this is the permutation formula. Well, the combination formula has 2 things we're dividing by. So it's n factorial, this first amount of elements in the group, and then you're choosing r elements from it. So we do n factorial divided by n minus r factorial divided by r factorial. So we do this extra r factorial here, which is why our number's smaller, because we're doing an extra division. Now when you do this on your calculator, you either use this button, which when you go to that statistics part under math, you can see how to use this button. I think it's right above or right below the NPR button. Or if you just want to plug it in, you should do n factorial divided by n minus r factorial divided by r factorial. So make sure you do divided by twice, or you have to parenthesize this entire thing like that. So it's probably safe just to use this. However, there will be a time when you need to do something like that. Okay, remember the first term always has to be, this first number has to be bigger than the second number, and they must always be positive or equal to 0. Okay, so let me just go through permutation and combination. Let's say we have Alex, Brenda, Chris, and Danielle as a group of 4 people. And I want to choose a president. I want to make one a president, a vice president, and a secretary. So how I choose them matters now. So I could make Alex the president, Brenda the vice president, and Chris the secretary. Or I could do Alex, Chris, then Brenda. Or I could do Brenda, Chris, then Alex. Or I could do Brenda, Alex, and Chris. Or I could do Chris, Alex, Brenda, or Chris, Brenda, Alex. So I think I've exhausted all the possible ways to do it with those 3 people. But see how this order, ABC, ACB, ABCA, BAC, CAB, CBA, they're all different outcomes because I've given them different titles. Now that's only using ABC. What if I chose the letter combinations of, let's do a different color here. What if I then instead chose A, C, D? So if there were 6 ways to do it with these 3 letters, then there's going to be 6 ways, right? 6 different ways to write it with these 3 letters. So again, it would be A, C, D, A, D, C, C, D, A, C, A, D, and D, C, A, or D, A, C. Okay, but again, those aren't the only 3 letters I could use. I could also use A, B, D. So with that 3, I could have 6 different ways of arranging them, just like I did here. And then finally, what am I missing? I have A, B, C, A, C, D. I have A, B, D. Now I need B, C, D, which again would be 6 different ways. Or going back to the permutation, it would be NPR. There's 4 people. I'm choosing 3 of them. So that equaled 4 factorial divided by 4 minus 3 factorial. So that's 4 factorial divided by 1 factorial. So that's just 4 times 3 times 2 times 1, which is 24 different ways. I could name Alex, Brenda, Chris, and Daniel, give them titles, right? And I could list them all out, but that's just a big pain. So this right here is a permutation, what we learned last time, because the order in which I choose those people matters. Now, if I did a combination, right, so combination, I just said the order doesn't matter. So an example of a combination would be for me to say, okay, I have Alex, I have Brenda, I have Chris, and I have Danielle, but I just need 3 of you. I just need 3 of the 4 of you to come help me with a project or to be a group to make a decision. So I'm not giving them titles, I'm not saying vice president, then president, and the secretary, I'm just saying I need groups of 3. Well then if you look at this big combination here, right, if I just need a group of 3, well then A, B, C, and A, C, B, B, C, A, if I chose Alex first, then Brenda, then Chris, or Alex and Chris, then Brenda, or Brenda, then Chris and Alex, or Brenda, then Alex and Chris, does that give me any different result? No, it doesn't. It's the same 3 people. So this entire group right here of 6 different ways for my permutation now just counts for 1. So this would be 1 different way for these 3 letters, 1 way for these 3 letters, 1 way for these 3 letters, A, B, D, and 1 way for the 3 letters of B, C, D. And then if you do it formulaically, remember it's 4, choose 3. And what we just saw, that would become 4 factorial divided by 4 minus 3 factorial, but then we have to give the extra r right here. So that becomes 4 factorial divided by 1 factorial, 3 factorial. Well, that's 4 times 3 times 2 times 1 divided by 3 times 2 times 1. These all cancel. So as I just said, this 24 ways shrinks down to only 4 different ways because these 6 combinations are really just equivalent to the same original group of 3. Probably not going to be emphasized too much, however, there is a little signal in each problem to indicate whether it's permutations and combinations. The lucky thing for you guys is that they were in separate units, so it really shouldn't necessarily come up. I might give you one question that asks you between the difference, you'll see that in the notes today, but otherwise you just always do the combination formula because we're in the unit that has combinations. So it's kind of nice that you don't have, that we didn't mix them together. Alright, so let's go back to our notes and just do some practice problems now. Okay, it says a menu at a Chinese restaurant contains 48 main dishes. A group of friends chooses 6 different dishes, and how many ways can they do this? So again, the difference between if I have 48 dishes and I'm choosing 6 of them, does the order in which they put those dishes on the table give you a different meal? No, it doesn't. Right? So we have 48 main dishes. They could bring out the rice, the fish, the chicken, whatever, all these different dishes. It's all still the same meal. So the order in which they bring them doesn't matter. It's still the same 6 dishes. So therefore it's a combination. So what do? You plug it into the formula, or you just use your calculator. 48 factorial divided by 48 minus 6 factorial divided by 6 factorial. So grab your calculator, I need to do the same thing. So I get a whole bunch of ways we could do that. So it looks like 12,271,512. That was 48, choose 6. Now, if the order did matter in which we ate them, maybe we were doing a 6-course meal, so the 6 dishes I chose does matter because they could come in a different order and create a different 6-course experience. That would be a permutation. But this isn't. This was just all the meals, Chinese style, going to be put on the round circle, spun around, and shared together. All right, moving on. Suppose 13 players from a football team of 52 are chosen for drug testing. How many different ways could 13 players be chosen? Again, the order in which they choose the players doesn't matter. They're just going to go out and pick 13. If I chose Sam before Joe or Chris before Sam, it doesn't matter. It's still Chris, Joe, and Sam are all going to go to get their drug test. So the order doesn't matter. It's 52 players. We're choosing 13 of them. Just use your calculator under the math button. 15 choose 13, and I get a huge number. So I get 6.35 times 10 to the 10 to the 11th power. So 52 people choosing 13 at a time. I get a huge number. Again, if you get something to contradict it, let me know. I don't ever go back and really watch these videos again, so you'll be the one to tell me if there's an error. Okay, so this is the one with the multiple scenarios. It says solve for each. Notice the difference in each scenario and its calculation. 20 students are semifinalists for three scholarships. One person will get $1,500, one person will get $1,000, and one person will get $500. And how many different ways can the scholarships be awarded? So, does the order in which you are chosen matter? Absolutely. Wouldn't you rather have the more money, which is $1,500 as opposed to the $500? So I can have three different people and make three different scenarios because I could have Alex, then Brenda, then Chris. Alex getting $1,500, Brenda getting $1,000, then Chris getting $500, or Chris getting $1,500, Brenda getting $1,000, Alex getting $500, or Brenda getting $1,500. So again, we're going back to that scenario. So if there's 20 students and I'm choosing three of them, this time the order matters, so I'm making it a permutation. So my results should be bigger. I should have more possibilities for this. So just plug this into your calculator. 20, I'm choosing 3. So there's 6,840 different possibilities, ways of awarding people, 3 different people from 20 students scholarships. So there are 6,840 different ways. However, if I make all the scholarships the exact same amount, so every single one of the 3 people is going to make $1,000, well, does the order in which I choose them matter now? No, because they're all in the same playing field. They're all earning the same amount of money. So it doesn't matter. So we just say 20. This time it's a combination. We're choosing 3, right? So again, plug it into your calculator. 20 choose 3. We should have less possibilities because for every 3 A, B, C, C, A, B, B, A, C, those 3 letters being used, it was the same result. So they're kind of counting each other out. So your combination result should always be less than your permutation result. Okay, let's move on. Maybe pause now and try some of the ones on the back, see how you do, and then you can check your answer as soon as you're done. Okay, your favorite type of problem. Funny that we paused here. I'm sure you guys were stuck, but the formula says we're going to take the left-hand side, n plus 5 factorial, and divide it by the difference between these two. So that's n plus 5 minus 1. Well, n plus 5 minus 1 becomes n plus 4, right? This right here becomes a positive 4. So we have n plus 5 factorial divided by n plus 4 factorial. And then, of course, we repeat this r, 1 factorial, but 1 factorial is just 1, so I let that disappear. For the second one, we have n factorial divided by the difference between these two, which is n minus 2 factorial, divided by the r factorial, or the second number. And we get this. So here we have it. Now I put it all together and I start to write, what does this mean? This means n plus 5 plus 1 less than that. So it would be times n plus 4, n plus 3, and this would be the denominator would be n plus 4 times n plus 3 plus times dot dot dot. Here this would become n times n minus 1 times n minus 2, etc. This would become n minus 2 times n minus 3, etc. So all of these cancel, so I end up with just an n plus 5 on the left-hand side and an n squared minus n on the right-hand side. So if I move everything to the right-hand side, I get n squared minus 2n minus 5 equals 0. And here you would either try to factor it, or it's not going to be factorable, so you're going to have to use a quadratic formula. Okay, so a little bit gross, or you can try it. So go ahead and plug it into your calculator or use quadratic formula and see what you get. Okay, either graph this and check your zeros, or use quadratic formula, which is right here. You should have gotten 2 answers of negative 1.45 and 3.45. To see the last few questions, look for part 2, and I'll explain all of those next. All right, so talk to you soon.